Am I audible now? Clearly. So J is equal to NEVD, where J is where J is current density, right? Where J is current density. Where J is current density. And E is electronic charge. Electronic charge. And we know that VD is drift velocity. Drift velocity. So this is the thing. Or I can also write it like this. We also write sometime I equal to J dot or I is equal to JA cos. This is also how we relate between current density and area vector. Yeah. So this is basically if we talk. So we will do some questions based on basics. Then we will move to slide. So let us do first some basic questions. If you see the first question, which says which of the following graph represent the variation of resistivity with temperature. So we know that for metal, resistivity increases with temperature. For metal, resistivity increases with when temperature increases, resistivity increases. So what will be the correct option for question A? What we should be? Okay. So I am saying resistivity increases with temperature. For metal, resistivity increases with temperature. It always increases with temperature. So if you see about resistivity, what happens is like this. For metal, what happens for metal? Resistivity varies like this. It's a linear variation, right? When temperature rises, resistivity rises. This is not this capital T. So when temperature rises, resistivity rises. It's a linear variation. It should be like this. Getting my point? Which is the correct option? Because it should increase with temperature and it's a linear variation. What should be correct option? Correct. It should be D. Right. Also see question number 2. The solid which have the negative temperature coefficient of resistance. Means temperature with increase in temperature resistance decreases. That happens with what will you answer for 2? Go through question number 2. No, insulator cannot have resistance. You know that insulator have infinite resistance. So with for semiconductors, what happens for semiconductor is, in case of semiconductor, what happens? With increase in temperature, resistivity decreases. Reverse of metal. For insulator, we know that resistance is infinite. So there is no question of variation. For insulator, we know that resistance is infinite. No current can pass. Current is zero from insulator. So no question of variation. So what happens for semiconductor, resistivity decreases with temperature. It means it will have alpha will be negative since resistivity decreases. That is why it is called negative temperature. Understood my point? What should be the answer? What should be the answer? Tell me the answer. So what should be the answer? Refer question 2. Refer, tell me answer for question number 2. I think you were disconnected. Again, see, we know that for semiconductor, resistivity decreases with temperature. When temperature rises, resistivity of semiconductor decreases. It means temperature coefficient of resistivity is negative for semiconductor. For insulator, we already know that their resistance is infinite. So no question of variation, right? So now tell me what should be the correct answer. What should be the correct answer? All right, correct. B should be correct. So B is the correct answer, right? Semiconductors. Moving to next question. Do question number 4. This is now also NEET 2020 question. So go through this question number 4. Go through question number 4. I will give you a hint. We know that what is mobility. Mobility mu is equal to drift velocity upon electric field. This is the formula for mobility. You may have studied this. V is equal to Vd by E. Apply that and get me the answer. So if you will apply that, what is the Vd? 7.5 into 10 to the power minus 4. What is the electric field? 3 into 10 to the power minus 10. So 2.5 into 10 to the power 6. So the correct answer is understood. This is NEET 2020 question. Okay. All right. So correct answer is. Moving to the next question. So this was question based on basics which we have studied. Now moving to the next concept. So we'll move to the next concept, that is Ohm's law. All right. What is Ohm's law? We all know V is IR, where R is resistance, where R is resistance, I is current. I is current. Also, we know that this is only valid at constant temperature. This is very important. This is valid at constant temperature only, because R should be constant, right? If temperature changes, then R will change. So this formula is only valid at when T equal to constant. This is the condition for validation of Ohm's. T should be constant. T is constant. What is R? We know that resistance is also given by rho L by A. If there is a metal having cross-sectional area A and its length is L and material resistivity is rho, then its resistance is given by rho L by A, right? So it depends upon geometry as well as material. If its radius is R, then area will be pi r. So we have to take area of cross section, right? So based on this, understood this one? Any doubt? All right. Based on this, we will do some questions. Then we will move forward. So let us do question number 7. Let me do some latest question. Like, so do question number 10. Question number 10. Attempt question number 10. It's a NEET 2008 question. Time this one. Okay, so what it says, a wire of a certain material is slowly stretched to 10 times, 10%. This new resistance will be a specific resistance. So what is it is, suppose we have a wire and it is stretched, suppose its length is L and it is stretched to 10 times. New length becomes, it is stretched by 10%, right? So L dash is L into 1 plus 10 by 100. Its length increases by 10 times, it means L into 1 plus 1 by 10. So it becomes 11 by 10 new length. So we have to find the new resistance. So suppose initial resistance is R and new resistance is R dash. So we know that R dash will be rho L dash by A dash. Suppose its area of cross section is A, now area of cross section is A dash. So we know the value of L dash is known, but we don't know A dash, right? So how we will calculate A dash? So to calculate A dash, we will apply volume concept. Volume will remain constant if you are increasing length, but volume will remain same. It means A into L will be equal to A dash L dash. So from here, L dash can be find out. Sorry, A dash can be find out. This will give you L dash, A dash will be equal to L upon L dash into A. So what is L upon L dash? From here you can see this is L dash. So L upon L dash is 10 upon 11, right? So it will be 10 upon 11 A. So now easily we can find the new resistance. We'll put the value. So here rho into what is L dash? L dash is 11 upon 10 L, and what is A dash? A dash is 10 upon 11 A. So from here you will get equal to rho L by A into 11, yani 120 upon 100. So you will get it as, and we know that it is R, so R into 1.21, right? So new resistance will become 1.21 time. And a specific resistance depends upon property of the material, so it will remain same. So correct answer is B. Understood my point? Any doubt? Okay. So this is how we should proceed for calculation of resistances. Okay. So this was the concept of resistance. Now, generally questions are asked based on this. Let us do one more question based on this. Then we move to the next concept. See question number 11. Let us see question number 11. So go to the question number 11, attempt this one and tell me the answer. So your answer is C. Okay, let us check. So what it says that the resistance of a certain wire is R. Suppose we have like this, and its resistance is R. Length and radius both are double. So what happens? Length is also doubled and the distance is also doubled. So R dash become it's not R dash. R dash suppose its radius is R, so R dash become 2R and L dash become 2A. Its original length is A. So we have to see resistance R dash. Right. So what is R dash? R dash is equal to rho L dash upon A dash. So rho what is L dash? 2L. And what is the area? Area is pi R dash square. So rho 2L upon pi R dash is 2R. So 2R square. So it will be equal to rho L by pi R square into 2 upon 4, right? 2 upon 4. So it will be rho L. If pi R square, we can say this area A is equal to pi R square, initial area. So we can say it rho L by A into 1 by 2. So what will happen? The resistance will be half and the specific distance will remain. So your answer was correct. Understood this one? So C is the right answer. All right. So this was about calculation of resistances. Now we will move to the combination of resistance. Next topic is combination of resistance. Understood this one? All right. Now moving to combination of resistance. So we all know there are basically three types of combination. One is series combination. What happens in series combination? We know that resistors like this connected N to N are called in series, like R1, R2, R3, and so on. So if N resistance are in series, then equivalent resistance is R1 plus R2 plus R3. Here what happens? Current remains same. Current through each resistance will be equal. So I is same, potential is different. Potential is different. So potential across each resistance will be different, but current will be same. Second is parallel combination. This was series combination. With parallel combination, what happens? The resistors are said to be in parallel if they are connected between 2 points like this, like this. So the resistance R1, R2, and R3. So here what will happen? Potential will be same, and current will be different. Suppose here we have current I1, I2, and I3 like that. So in parallel combination, 1 by R equal to 1 by R1 plus 1 by R2 and so on. So this is the parallel combination. Understood this one? Yeah, this is already this is very basic concept. So the main concept behind series and parallel we will come to know when we will do practice. And we will also have mixed combination. In mixed combination we will have both series as well as parallel combination. Understood? So directly we will move to the question. Then we will, and apart from that, so moving to the question. Understood this? Okay. So based on this, we will do this question. Do this question number 6. NEET 2017 question. So attempt this question. This one is, I think, this is based on previous concept, I think. Let us do this. This is based on previous concepts. I will give you this as homework. Leave this question. This is not based on combination. I will give you this as homework. So move to next question. This question 6, you can attempt it later. This is only based on previous. So now moving to the combination of instances like this. So do this question number 20. Do this question number 29. Question number 29. Attempt this one. Attempt this question number 29. So we're getting R by 4. Let us see. When a wire of uniform cross section is length L bent into a complete circle resting between any two diametrically opposite points. So what question says is, suppose we have a wire of length L and area of cross section A, and it is then bent into a completely circle, right? It is bent into a circle. Then we have to find resistance between any two diametrically opposite points. Suppose these two points are A and B. So we have to find the resistance between points A and B, right? So what will happen? Total resistance is R. So upper portion will have half radius and lower portion will have half. Understood? Since length is half, now it is connected in parallel like this. R by 2 in parallel, R by 2 in parallel. So the net resistance will be R by 2 divided by 2 means R by 2. So the answer is correct. Okay. Going to the next question. Now attempt question number 33. 10 question number 33. Attempt this question. We have to find the equivalent resistance between the points A and D. Are you trying? Yes, 30 is the correct answer you have got. Now we got 30. What we have to do is here we have to calculate the resistance between A and D, right? So for that we have to remove these resistors. Remove this and remove this. The equivalent network will be like this. Like this. Now this become 10. This is 10 10. So this will become 20, and this is also 20, and these are in parallel. So their net equivalent will be 10. So this 10 and we have other 10s. These two 10s. Combined, these all are in series. So net resistance will be 10 plus 10 plus 10. Understood? I will do the same way. Alright. So this is how we should apply series and parallel combination. Let us try more. Do this question number 39. So before that, I will explain you one Wheatstone bridge concept. Is that same as capacitor? You all know the Wheatstone bridge concept. What is that? Same as capacitor. Like we have four resistors connected like this. Suppose this is R1, this is R2, this is R2, and this is R4. Is connected to a cell. So, and there is a resistance R5. Suppose there will be 3. So what happens is if R1 R3 is equal to R2 R4, then it is balanced. Then this is balanced, and we can remove R5. You already know that, right? So current through R5 will be 0. Here current through R5 will be 0. Understood this one? What is the Wheatstone bridge concept? Same as capacitor. So you'll also see some question based on this one. So based on that, first we will do some question based on Wheatstone bridge concept. So based on that, do this question number 96. Do this question number 96. No, not 96. 4 for 96. Don't do 96. Do this question number 109. Do this question number 109. Are you trying this? So how to solve this question? Any idea? This is basically a Wheatstone bridge, right? You don't go through directly. If you see how to identify a Wheatstone bridge, the product of, you got 5 by 18, right? Let us see. So this is basically a Wheatstone bridge. If you see, multiply of opposite resistors 12, and this is also 6 into 2, 12. So this can be removed, right? Now 4 and 2 are in series, so there will be 6 ohm parallel with 9 ohm. 6 ohm will be parallel with 9 ohm. Their equivalent will be 6 into 9 by 6 plus 9. So 54 by 15. 18 by 5, and I will be V by R. So V upon 18 by 5 So 5b by 8. Your answer is correct. 5b by 8. So this is how to solve question based on what is from there, right? Same with this question number. This question number 114, right? Same concept is there, so I will give you assignment. You can do that. Question number 114. 114 is same. All right. So this is how we should solve. Now moving to the next concept, that is combination of cells. So in the same way as combination of resistances, we have combination of cells. Combination of cells. So what are these? There are two type of combinations. Basically, there are three: series, parallel, and mixed. So generally, we will go first with series combination. What happens in series combination? Like two cells we have internal resistance R, EMF is E1 R1, and another is like E2 R2. Then what is equivalent EMF? E equivalent is given by sum of in series combination. The equivalent EMF will be given by E1 plus, right? And R equivalent, what is the equivalent resistance? R1 plus. For n number of cells, it will increase. Like we have n number of cells, then it will be E1 plus E2 plus E3 and dot E. And also resistance will be like R1 plus R2 internal resistance. In the similar way, we have parallel combination of resistances of the cells. In parallel combination, what happens? What happens in parallel combination? Like we have cells, we have one cell of EMF E1, have internal resistance R1, and we have another cell of EMF E2 and internal resistance R2. These are combined in parallel. So in that case, what happens? E equivalent is given by like this: E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1. This you have to directly remove. E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. This will extend for n number of cells. For n number of cells, it will be like this: E1 by R1 plus E2 by R2 and so on. En by Rn divided by 1 by R1 plus 1 by R2, so on. Understood? So this is how we can calculate equivalent. Getting my point? Any doubt? We will some question. We will see some question based on combination of cell. Then we will move to pressure of gas. To do question number 58. Question number 58. We have to find the voltmeter. Okay. Option. And this question number 58. Are you trying? So you got 14. So this is actually parallel combination, right? So this is a parallel combination of 6. So we will apply the same formula. E equal to E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So 12 by 1 plus 18 by 2 divided by 1 by 1 plus 1 by 2. So we will get 12 plus 9 divided by 3 by 2. So we get it right. 21 into 2 by 3. So 14. The answer was correct. We get 14. But in the same way, it's a parallel combination of cells. Alright, so this is how we should proceed for parallel combination of cells. Now moving to the next concept, that is Kirchhoff's law. That is very important. So basically we have two Kirchhoff laws. One is called Kirchhoff junction law or Kirchhoff current law. Kirchhoff's junction law or Kirchhoff current law, or also known as Kirchhoff first law. Then we have Kirchhoff voltage law or rule, or it is also known as KVL. or Kirchhoff second. Both are same. So first we will see Kirchhoff junction law, KCL. Then we will see KVL. So what KCL says? Actually, it is based on conservation of charge. It is based on conservation of charge. Conservation of charge. So how it is happens? Suppose we have a junction, and at the junction we have number of current like I1, I2, and outgoing current is I3. So here what will happen? I incoming will be equal to I outgoing. It means I1 plus I2 should be equal to I. This is the concept. The charge coming will be equal to charge outgoing since charge is conserved. Understood this one? So this is what conservation of KCL says. The algebraic sum of the I'm not going into the definition. The definition is the algebraic sum of currents meeting at a point is zero. So here what it is, what it says, or we can expand it. Understood this one? KCL, very easy. Understood. Based on that, I will give you one question based on KCL. Suppose, or let us see some neat question based on KCL if there is. Okay, very good. So I'll give you one question to solve for KCL like to find the value of I here. A wire has junctions like this. So we have to find the value of current I. Find the value of I. Understood the question? I think you were disconnected. So when I was teaching KCL, or you were there, you understood KCL, right? Okay, so based on that, I have given you the question on the screen. Solve that. Solve this question. We have to find the current I. Are you trying it? You got 4 by 7. Let us see. This is 4 ampere, right? This is 1 ampere. What will happen when they meet at the junction? What will be current flowing here? 5 ampere. Understood this one? How it is 5 ampere? When they will meet at this junction, 4 ampere is coming from this side, 1 ampere coming from this side. So both will meet together and 5 ampere current will flow here. Not 2 ampere is going outside. So what will be this 3 ampere? Understood? So correct answer is 3 ampere. So how this is junction lines apply? Understood? So now quickly solve one question. Let us see. Quickly solve question number 42. Question number 42. So read it properly and write it in the paper and try it as a homework. Question number 42. And we will do in the next class, we will do Kirchhoff voltage law, and we will do some questions based on Kirchhoff voltage law. Then we will do electrical instruments, right? So for today, I'm ending here.